Alright, so here's a second video, finding the magnitude and direction of a vector. Like I said in the first one, I will do 4 examples. Each example will have its own video. The first example 1 is where the vector was in the first quadrant. This example, the vector will be in the second quadrant. Example 3, the vector will be in the third quadrant, and example 4, the vector will be in the fourth quadrant. So, check them all out so you'll see all the different scenarios. Alright, so let's look at this again. We have the magnitude of a vector u, AB, is given by, and then this is the magnitude of vector u, is equal to the square root of a squared plus b squared. So it's just this squared plus this squared, and then you're taking the square root of it. And the direction angle, theta, satisfies tangent theta equals b over a, where a is not equal to 0. So that would be this term over this term. Tangent theta equals that. Alright, so let's take a look at our example. Alright, so find the magnitude and direction angle. Now, whenever you're doing this, always plot it. Draw a picture of it first. Okay, so let's plot this. -7, 24. So the -7, we know we're going to come over here to the left, and the +24 will go up. Now, I don't really care if I go up exactly 24 and to the left 7. Okay, the main thing I want to know is, where is this point, or where is this vector? Well, if I go -7, that's to the left, and +24 would be up, so I can see that it's here in the second quadrant. And so this would be my theta. Okay? Alright, so now let's go ahead and find the magnitude. So the magnitude of vector u would be the square root of -7 squared plus 24 squared. And this, we will need to put this in our calculator. And then I've got the, let's see. Okay, so it turned out to be 25. Okay, so that's the magnitude. That's this distance from here to here. That's my magnitude, 25. Now I need theta. Okay, so I know that I have tangent theta is b over a. Okay, now I can't just do the inverse tangent of this. Okay, look what happens if I just do the inverse tangent of 24 over -7. Okay, that gives me -73.74 degrees. That's if I just take the inverse tangent of this. Well, what's -73.74? That's down here. See, that would be down here, -73.74 degrees. Okay, that's not right. Okay, see, my angle is over here. So what I need to do is I need to find my reference angle. See, I need to find a reference angle, and then I can use the reference angle to get theta. Okay, so how do we do that? And I just use this apostrophe to represent the reference angles. Some textbooks use different symbols. Okay, but that's all this apostrophe means, is reference angle. Okay, so I have tangent, and I'm going to change this to the reference angle. And anytime you're looking for the reference angle, the tangent of whatever your reference angle, this term here has to be positive. Because when I do the inverse tangent of a positive number, it's going to give me an angle in the first quadrant, which, remember, your reference angle is an angle measure in the first quadrant. Alright, so I get theta prime, and then I'm going to do the inverse tangent of 24 divided by 7, and that gives me 73.74 degrees. That is my reference angle. This is 74 points, I'm sorry, 73, my reference angle, 73.74 degrees. That's my reference angle. Well, so how am I going to get theta? Well, theta is going to be what? 180, and then I'm going to subtract off. See, if I go 180 and then I subtract off the reference angle, I'm left with just this part. So minus 73.74 degrees. And so let's see, 180 minus 73.74. That is going to give me 106.26 degrees. So there's my direction angle, and there's my magnitude. Okay, it's very important that you get the reference angles. Okay, all right. So I hope this video helped. And like I said, check out the other ones. The example 3 and 4, there will be third and fourth quadrant angles. All right. So don't forget to like and subscribe and check out my other videos. Thanks.